Okay, last time we have we stopped at the concept of how to find the probability value if you are using the first table. That will be on the page of somewhere 59, 60, 60, 61. Okay, so if I'm not mistaken, we finished at somewhere, okay, somewhere over here. Am I correct, class? At the exercise 2.6 of how we can use the first table, which cover the middle area to find the probability value. Example 2.6. Okay, so am I right, class? We stopped at first questions and we did not manage to finish with the second question, right? Now, are you all listening to me, class? Can you listen to me, class?
Yes, madam. Yes, madam.
Yes,
Okay,
madam.
thank
Yes.
you. Oh, okay, thank you. Now, find the probability of z between -1 and 1, -2 and 2, -3 and 3. How do these values compare with the empirical rule? So, if you look at the empirical rule, I'm really sorry, the empirical rule should follow after this question actually, but somehow I mistakenly put the empirical rule after the upper tail probabilities. Okay, what does the empirical rule tells you? Okay, the empirical rule tells you if we are talking about one standard deviation, okay, one standard deviation, so we are talking about from the mean, which is at the center, to one standard deviation from the mean. So one sigma, and that will give you how much probability value? That will be 68%. If you are talking two standard deviation from here until here, so let's say the green color, so from here until here, or from here until here, so you are talking about two standard deviation, 2 sigma, -2 sigma, here +2 sigma. Okay, and the same goes to, for this 2 sigma, you are talking about 95%. Okay, and for the 3 sigma, let's say orange color, from the mean until the 3 sigma, so this is +3 sigma, this is -3 sigma, and the probability value is 99.7, which cover the whole area here. So for 99.7%, for the green one, 2 standard deviation, so it will be this area only, and for the 1 standard deviation would be from here until 1. Okay, so how does that relates to these particular equations? Okay, simple, because if you are talking about the first one, p -1 z1, so you are talking about this division. Okay, 0 is 1, 1. So you are talking about this particular area. So you are talking about z is equal to -1 or 1. So since we are using the half, the positive, what we call the positive side of our distribution. So 1.0, this is the value of z, the first column, and the first row. This is referring to z value. 1.00 is 3.3413. So 0.3413. Here, 0.3413. If you add this together, this will give you 68.26%. Right. If you're talking about -2 and 2, okay, so -2 and 2, -2 and 2, so this will be the area. of negative 2 and 2 to look for for 2.00, so you will get 0.4772. So half of the area here is 0.4772, 0.4772. That's why for the green area, you will have 95 point, that would be 95.44%. Okay, and for the third one, that will be for 3 standard deviation. So from negative 3 until 3. Okay, so let's say, not much different, so let's say blue color. Okay, so the blue color, okay, so this will be 3.00 will give you 0.4987. So 0.4987. Here, half of it is 0.4987. So you can say for 3 standard deviation, you will get 99.74%. Okay, so this it proves that in terms of okay, standard normal probability distribution, negative 1 to 1, negative 2 to 2, negative 3 to 3 will follow exactly the empirical rules that we talked about earlier on. Okay, so that will be on the last exercise for 2.6, number 2. Now, let us look how the probability that involved in the upper tail area. How are we dealing with this kind of what we call probability value? Now, unlike the first what we call probability or area under the curve, now we are referring to the area that bound by this particular area. Okay, so you are talking about the whole thing here is z value. Okay, where you refer to z value, the first column, and the first row. If you are talking about z equal to 2.05, okay, 2.05, then 2.05. So the z value is here, 2.05. The probability value is 0.4798. Which area? This will be 0.4798. Okay, with the given z. If you are talking about upper tail, okay, again we are talking about z at the x-axis. We are talking about z. Okay, but this z is guided by the probability value at the upper tail. Okay, so z alpha is the one that is given in here, and it is based on the probability value here. That's why your alpha is now in the first column and the first row. If let's say I'm talking about alpha equal to, let's say, 0.071. Alpha 0.071, that will be 0.071. So my z alpha is 1.4684 here. Okay, so if I were to write it down again, so my alpha is 0.071. What is my z value here? That 0.071 is 1.484684. Okay. Unlike the first one, we refer to z, then we find the probability. Now the other way around. Let us look at a few examples. Okay. The first example is 2.16 on page 62. Okay, 2.16. Determine the Z alpha. So if you are referring to Z alpha, let's say we know that the mean is 0. Okay, so the alpha value is 0.25. This is 0.25. The probability value is 0.25. Now I need to find what is the Z alpha here. Z alpha, that is Z 0.25, 0.25, 0. So we know that our Z will be 0.6745. Okay. What if I'm talking about TZ less than? Okay. 0, Z alpha. We don't know. Sometimes you have to ask, where is my location of Z alpha? In this case, obviously, greater than, this is the area, greater than, and the probability value suit the area under the curve. Very small probability. What if now you have alpha, you are talking about alpha 0.36. Let's say I put it alpha here, 0.36. 0.36. But now look at the sign. If I'm talking about the sign less than, it should be the area less than here. So in this case, 0.36, the Z alpha here is wrong. Okay, so now you need to ask, okay, what if my Z, my region is somewhere over here? Okay, which is 0.36, and I'm talking about Z alpha, which is Z alpha negative value. So in this case, for 0.36, and we know that the Z alpha is 0.3585. Okay, now since this Z value suit this particular probability value less than Z alpha, so we know that this becomes negative because this is the area of negative value, this is the area of positive value. Okay, now that will be the first on how we can use the upper tail table. Now find the Z value such that the area under the Z curve between 0 and Z is 0.2123. Okay, now you are talking about area under the curve from 0 until Z alpha. Let's say this is your Z alpha, and the probability given is 0.2123. Since we need to find using the upper tail table, we know that we are referring to the probability value here. So how we can find alpha here? Easy, because half of this is 0.5. So 0.5 minus 0.2123, you will get the alpha here. So alpha is equal to 2.17. So you will get 0.2877. Okay, so that will be your Z alpha. So how do you get your Z alpha? So for alpha 0.2877, or you approximate that into 0.288. So you will get your Z alpha is equal to 0.5592. Okay, that's why you get the Z alpha 0.5592. If you have any question, ask me, okay? Because I will just proceed with the question. Now, exercise 2.7. So, exercise 2.7 on page 62. Okay? If Z is the standard normal random variable, find the value of Z for each of the following. Okay? The area to the left of Z is 0.9750. So, if you sketch the area under the curve, okay, area to the left of Z, okay, we know that Z is equal to 0 in the middle. Now left of Z, which Z? If I choose Z here, less than the probability value is higher. So there is no way the Z alpha that we are talking about is here. So we take another Z alpha. So Z alpha, let's say Z alpha is somewhere over here. Z alpha is somewhere over here. And the probability or the area to the left of Z, to the left of Z is this part, is 0.9750. So we know that in order to use your upper tail, we use this particular region. And in order to find the particular region, we know the whole probability is 1 minus the probability of the shaded into 0.9750. You will get alpha equal to 0.025. Okay, 0.025. So look for 0.025, 0.025. So we know that Z alpha that we are talking about is 1.96. Okay. Now the area between 0 and Z is 0.4750. Okay. Second, from 0 and Z, okay, let's say this is your Z alpha is 0.4750. Then, knowing that we use the tail, so this would be 0. Obviously, it's too small. It should be somewhere in the tail. Okay, 0.5 minus 0.4750. So your alpha is given by 0.025. So again, your Z alpha 0.025. Your Z alpha is 1.96 positive. Okay. Now the third one, area to the right of Z. Area to the right of Z. So Z equal to 0. Area to the right. Let's say Z alpha is here. Area to the right, very small probability, is 0.133. Okay, so directly from your table, 0.133. So obviously your Z alpha is 1.112. Okay, so that's how we find the probability value using the upper tail table. Let's look at the second question. Find the Z value so that 48% of the middle area of the Z curve is bounded by them. So if you look at the probability value is 48% of 0.48. Okay. So bounded between the Z value, is Z equal to 0, Z alpha negative, Z alpha positive. So you are talking about 0.48. So you are talking about this area. Okay. So in order to use your upper tail table, as usual, we are going to use the what we call the upper tail. Okay, so finding the alpha, alpha is 0.5 minus divide by 2. This part will be 0.24. 0.24 alpha is obtained by 0.26. Okay, so look for 0.26. 0.2 is not here. If let's say I look from the table, 0.2 for the upper tail, 0.2, 0.26, right? 1, 0, 1, 2, 3, 4, 5, 6. 0.26, sorry, 0.26 is somewhere here. Okay, 0.26, right? Okay, so 0.6 is obtained by 0.6433. So we know that for Z alpha, for this will be 0.6433. Or you can write as Z 0.26 is equal to, okay, 0.26 is equal to 0, I mistakenly give, okay, I think I need to stop sharing, mistakenly give permission, okay, share it again, okay, so 0.64. Any question so far, class? Any question? Okay, if
No,
no
doctor.
question, let us look at the, okay, no question, okay. Now look at the question on the example 2.18. Example 2.18 is one of the example of how the real normal probability distribution question is involved. But somehow for the initial what we call example is directly on how you can use from the normal probability distribution convert into standard normal, then how we can solve that. And of course in your assessment, your questions will not be like somewhat like this. Okay, it would be somewhat a real problem given to you. So you need to identify how does the distribution looks like, what will be the definition of the x random variable given in your question. So everything will be done on your own. Now, suppose x is a normal distribution with the mean and standard mean and variance is specified. Find a probability of x greater than or equal to 24 and less than or equal to 35. So how do we deal with this kind of questions? Okay, so in this case, okay, so in this case, please understand x normal with mean 25 and variance 25. So this is the mean, this is the variance. Okay. Now, in order to solve the normal distribution question, remember we need to standardize back into standard normal. Why? Because if we were to have this, let's say we have a different mean, so you are going to refer to different the normal distribution table. But using standard normal, okay, with mean 0 and variant 1. So this what we call different problem will always refer to standard normal distribution whereby the mean will always be 0. Okay, so that's why we need to do the transformation. So in order for us to apply the transformation, what happened is that, so here P 24 minus 25 divided by standard deviation will be square root of 25 z. Remember, originally it is z x, and when you start transforming using standard normal, it becomes z. And 35 minus 25 divided by square root of 25. So you will get pz. So in this case, it would be negative 0.2 z until negative 2. So originally, okay, if I were to write in terms of the distribution, the mean is 25. Okay, but when I standardize them, it becomes, and you are talking about from 24 until 35. So you are looking for this particular probability value. And to use one standard normal table, we approximate into standard normal where the mean is 0. And now, once you have transformed, we know that it becomes negative 0.2 until 2. So this is the area or the probability that you are looking for. By using the understanding that we have discussed in the previous class, how to find this probability. Okay, so since we are talking about symmetric what we call distribution, this one can be obviously obtained from your first table, and for this particular region, which is in the red what we call region, so you can use by putting the value or the z becomes 0.2, and you are referring to this particular area. That's why your answer becomes probability of z between 0 until 0.2, the positive side, this part, plus the probability of z from 0 until 2. Okay, so if you look at your table, from 0.2, look at the first table. 0.2, you will have 0.0793, and for 2, you will have 0.4772. So put it together, the probability value. So you will have 0.0793 plus 0.4772. So you will get 0.5565. Okay, so that will be the probability value for the shaded region. Now, Px greater than 20. Okay, for number 2, Px greater than 20. Transform into standard normal. So Pz greater than or equal to 20 minus 25 divided by square root of 25. You will get Pz greater than or equal to negative 1. Okay, so you are talking about negative 1 greater than. Okay, so we know that we have two area. Okay, so by using the first table, you can use the concept of from 0 until 1 and 0 until the half of the area. So in this case, this becomes Pz greater than or equal to 0, the whole half of the area, that is 0.5, plus Pz from 0 until 1. So this will be 0.5 plus from 0 until 1. If you refer to your table, 1, so you will get 0.3413. 0.3413. So you will get 0.841. Done. Okay, so that would be the probability for the second one. Now, for example 2.19, okay, example 2.19, 2.19, okay, Malaysian consumes, okay, this is a good example of how real problem becomes a standard normal problem for you to solve. Okay, if I summarize as using your what we call given answer in your textbook, so your x is equal is defined by number of cups of coffee. Okay, and X distributed normally with average 1.64 and standard deviation 0.24. Since we are writing down the variance, so given is your standard deviation, so that's why we put square here. Okay, now if 500 individuals are selected, approximately how many will drink less than in your textbook less than 2, right? Okay, so P X less than 2. Okay, so transform into Z. So Z less than 2 minus 1.64 divided by 0.24. Okay, so in this case, PZ is less than, if you calculate, you will get negative 1.95. So if you sketch 0, negative 1.95 less than, okay, it's the same as here, greater than. So this will be, we are looking using the first table, so the whole 0.5, so that will be PZ greater than or equal to 0 minus PZ between 0 and 1.95. So that will be 0.5 minus, if you look from your table, 1.95, you will get 0.4744. If you deduct, you will get 0.0256. And in terms of percentage, this will be 2.6%. Or you can say 3%. Okay, so if 500 individuals are selected, approximately how many will drink less than 2? So you are looking for the number of drinkers, coffee drinkers. So that will be, in order to find using the probability that you have obtained, so 500 multiplied by 0.0256, you will get, you will get 12.8%. Or you can approximate to 13 people. So 13 people will drink less than 2 cups of coffee. Okay? So how likely this event will occur? Very small probability. So this event will is unlikely to occur. Unlikely to occur. So of course you have to write down all the full sentence. Okay, just to simplify, so this one will be unlikely to occur. Now, do you have any other example? Okay. Now, for the second example, example 2.19, okay, you are going to use your second table that will be involving the upper tail, or what we call upper tail probability distribution. Okay. Now, if we simplify, so since you have all the x is the mathematics score and the distribution is given by the x is normally distributed with mean 500 and standard deviation 100, so the variance is 100 squared. Okay, so this is your distribution of your x. What is the probability that the people taking the test will score below 350? So the first question, Px less than 350. Obviously, by taking the transformation, this becomes z less than 350 minus 500 divided by square root of 100 squared. So easy say it will be the standard deviation will be 100. Okay, so divided by 100. So you will get Pz less than negative 1.5. Okay, so pz negative 1.5 is equal 0, 1.5 less than the same as 1.5 greater than, which is 0.5 minus pz between 0 until 1.5. So look for 1.5 from your table. Of the first table, 1.5, 1.5, so 0.4332. 0.4332. So this will be given by 0.0660. Okay, so that is the probability. People taking the test and score below 350. Small chance or very unlikely that people taking the test will get less than 350. Now, the second question, which is most of the time, last time, if I were to have the assessment, the second question always been asked. Okay. Now, what is the question? Remedial assistance will be given to student in the bottom 10%. What is the maximum score? So, if let's say I put this in terms of their original the original distribution, okay. So let's say this is the distribution for this one. So the mean is 500. Okay. Now we are talking about remedial assistance. Means that those who score below, okay, who score below, which is what kind of below? The 10% below. So the alpha is 0.10. Okay, you need to find what is the x mean. Okay, when you transform, so that by using the transformation, what is your z alpha here that cater for 0.10 here? Okay, so the way we solve this would be in terms of, okay, we are looking for probability of x less than, okay, less than or equal to the maximum value, the maximum score of the lowest. So let's say we put max equal to, what is the probability? The probability is 10%, so 0.10. Now transform this. When you transform this becomes z, this becomes max minus the mean is 500 divided by 100 equal to 0.10. Now we are looking for this. What is the x value? So by using the understanding of z less than or equal to z alpha is equal to alpha. Okay, so taking this understanding to solve your equation. So max minus 500 equal, but divided by 100 is equal to 0.10. What is the, for alpha 0.10, what is my z alpha here? Okay, so look for your upper tail. Okay, upper tail for 0.10. 0.10. So this is your value, 1.2816. 1.2816 negative, because obviously it is among the lowest score, which is less than the minimum, less than 0. So negative 1.2816. Okay, so you can solve for max. So max is equal to 100 multiplied with 1.2816 plus 500. And if you solve this, the max value is 371.84. Or you can say 37. Okay, so what is the maximum score of this group of students? The maximum score will be 372 out of the average value, that is 500. Okay, Now, exercise 2.8. If you don't have any questions, I will proceed to exercise 2.8. Okay, in January 2003, if I'm not mistaken, is the latest textbook. It would be exercise 2.8. Okay, you are talking about Malaysian, not American, huh? Malaysian. But if we simplify, okay, in average, Malaysian workers spend on average 77 hours logged onto the internet while at work. Assume the population mean is 77 hours and the time are normally distributed and the standard deviation 20. Okay, so in this case, x is equal to what? X is equal to what, class? Huh? Hours spent log on internet. Hours spent log on internet. Hours spent on hours spent. Okay, more or less like. So x is distributed with normal and the mean is 77 and the standard deviation is 20, so the variance is 20 squared. Okay, now first question, what is the probability is fewer, x spent fewer than 50? Okay, so x less than 50. So first transformation to z score. So p z less than 50 minus 77 divided by 20. Okay, be careful, we are talking about standard deviation. Here is variance. Okay, so in this case, you will get pz is less than negative 1.35. And if you refer to your sketch, 0, negative 1.35, I'm really sorry for my very bad sketch. Okay, just things so adjusted, less than 1.35 negative, so it will be 1. So all you can say is this one. Okay, so Pz, this will be okay, so this will be Pz greater than or equal to 0, here, 0.5 minus Pz from 0 until 1.35. So look for 1.35, so this one is 0.5 minus 0 until 1.35, which is this area. So what is the value? 1.35. 1.35 is 1.1031. Sorry, we are talking about the first table. That would be 1.35. 1.35. 0.4115. 0.4115. So you will get 0.0881. Very small probability. Okay, so this one is for this one. Okay, now what is the percentage of workers spend more than 100 hours? Okay, so number 2, PX spend more than 100 hours. More than 100 hours. Okay, so again, this is straightforward. PZ greater than 100 minus 77 divided by 20. So you will get PZ greater than 1.15. So if put it in terms of sketch, 0, 1.15 greater than. So again, obviously 0.5 minus PZ between 0 until 1.1. So you will get 0.5 minus 0.3749. You will get 0.1251 or 12 or 15%. Okay, 15 or 12.151%. So what is the percentage? 13%. Approximation. A person is classified as a heavy user if he or she is in the upper 20%. Now you are talking about the upper 20%. So the upper 20% is 0.20. Okay, so if originally, if they log on more than a certain value of X, okay, we can identify or we can classify that as heavy user. So again, obviously, we are going to use the upper tail distribution to solve the equation. Now, let's say number 3. Okay, P X. Okay, so if in order for us to say upper 20%, so it will be obviously it will be greater than, okay, let's say some value of X here, X upper, okay, is equal to 0.20. Okay, so transform into Z, this becomes X upper minus 100, probability that minus 77 divided by 20 equal to 0.20. Okay, but when we solve this becomes X upper minus 77 divided by 20 given by Z alpha. What is your Z alpha for 0.2? So look for the upper tail 0.2, 0.20. So 0.8416. 0.8416. You can solve for X upper equal to 20 multiplied with 0.8416 plus 77. So X upper is obtained by 93.8 hours. Okay, so then we know, okay, if the user spend more than 93.832 hours, they are considered as heavy user. Okay, 93.832%. Okay, class. Understood? Understood, class?
Yes, doctor.
Okay, stop sharing for a while. Okay. 70 of you are with me, so I'm not sure what happened to the 10 or more than 10 of your friends. Okay. Let's continue with the approximation. Last part. Okay, last part of our chapter 2. That will be approximation for Poisson and binomial. What are the things that you should know when we need to approximate from binomial to normal, from Poisson to normal. Okay, now let us look at the first type, that would be normal approximation of binomial probability distribution. Okay, last time when you have your x following binomial and p, okay, you can approximate this become Poisson, right? Whereby your lambda is obtained by n, right? Am I right, class? All right, class. Okay. So what is the condition? The condition is n should be larger or equal to 30, and the other one would be np must be uh, np less than 5 or nq less than 5. So these are the things that we discuss about the approximation of Poisson, the Poisson approximation of binomial. Now, how can we approximate binomial become normal? What are the conditions? And how does the new distribution looks like? Okay, originally they are binomial with number of trial n and probability of success p, and this become normal where the mean is obtained by multiplying the probability of success with the number of trial, and the variance is NQ. Number of trial multiplied with probability of success multiplied with probability of failure. And what are the conditions? Okay, so for normal approximation of binomial, you have three conditions that need to be fulfilled. The first one is n is greater than or equal to 30. Second, if you multiply the number of trials with the probability of success, it will be greater or equal to 5, or the probability of failure multiplied with the number of trials, you have also get greater than or equal to 1. Okay, so that would be about the what we call normal approximation of binomial. Okay, now how does this possible? If you look at the probability distribution for binomial, okay, look what happens if you increase the number of trials from 10 and become 50 number of trial. What happens is that the probability distribution become symmetric. Okay, so in this case, symmetric, so it follows normal. Okay, that's why this become possible. Now, bear in mind, since in this case, we are converting from discrete to discrete. Now, you are talking about from discrete to continuous. Okay, since this transition is coming from discrete to continuous, there will be a continuation correction factor that needs to be integrated into your calculation. So that continuity correction factor will be if the given equation find exactly x. So you need to transform into new place of your what we call normal probability distribution. Okay, the same goes to if you are looking for probability of x less than or equal to certain value of x, then you will have to add 0.5. Less than 5 minus 0.5, greater than or equal to x minus 0.5. Then finally, for greater than x, it will be plus 0.5. So you have to make sure you remember all this, what we call continuation apply to your now. Example 2.21. I'm really sorry I cannot stop because I should stop now. I need to drink for a while. Okay. Pause. Okay. Now, the first example, how can we apply the approximation and how does the continuity correction factor involved in your calculation? Suppose that 5% of the population over 70 years old has disease A random sample of 9,600 people over 70 is taken. What is the probability that fewer than 500 of them have disease A? How likely the event will occur? Okay, so from your textbook, you can obviously see your X random variable is following by where the X is defined as the number of people over 70 years old as disease. So in this case, the success is having the disease A. Okay. Now, how many trials? Because it involves 9,600 people, so the number of trials is 9,600. And the probability given is 5%. So that's why we have the probability of success by having disease A is 0.05. Now, check for the condition. First, N is 9,600, obviously greater than 30. NP 9,600 multiplied with the probability of success, you get 0. Again, fulfill greater than 5. And NQ is 9,600 multiplied with the probability of failure, that is 9,120. Fulfill. Then we know we can approximate to normal. So when we approximate to normal, this becomes X distributed normal with the mean S and E, that would be 480, and the probability, the variance would be NPQ. So NPQ would be the variance. Okay, so NPQ is given by okay, NPQ is given by 456. 456. Okay, now the question, what is the question? What is the probability that fewer than 500, Px less than 500? Okay, since we do the approximation from discrete to continuous, so we have to use the continuity correction factor for less than. So less than will have to deduct by 0.1. So Px less than become less than or equal to 500 minus 480 divided by square root, so 456. Okay, and calculate for this, you will get Px less than or equal to, where's my eraser? Sure that how excited I am right now. So if less than or equal to minus 0.5, this becomes 499.5. Okay, so transform this into your Z transformation. So P Z becomes 499.5 minus 480 divided by square root of 461. Okay, so you will get P Z less than or equal to 0.91. Okay, so if I go to sketch 0.91 less than. So you have this area. Okay, so 0.5 plus this one. So this will be P z less than or equal to 0 plus P z 0 until 0.91. Okay, so you will get 0.5 this part plus 0.91 0.91 0.91, you will get 0.3186. 0.3186. Okay, so you will get 0.8186. Okay, now what is the probability more than 500? So this is the probability. So if we are talking about percentage, it would be almost 82%. How likely the event will occur? In what event? The event of fewer than 500 and having disease A is very likely to occur. Okay, likely to occur. Okay, any question class for the example? No question? Okay, if no question, I proceed with the exercise. Now,
No, doctor.
exercise 2.9, that is on page 56. Okay, a magazine reported that 6% of American drivers, so in your case, it's Malaysian driver, read newspaper while driving. If 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving. Interpret the probability calculated. Okay, so as usual, find your x. What is your defined x? Okay, what is your defined x? What is your x class in this case? What is your x class? Plus, what is your x defined? Plus, are you all with me? Hello? What is your x here? Remember, we are talking about binomial. So if we are talking about binomial, define x, it will be what? The number of what?
Driver are selected at
Right?
random.
Smartphone. Use smartphone while driving.
The number of what? No one is answering.
Driver are selected
Anyone
at
to
random.
try? The
Driver are
number
selected
of
at random.
Malaysian drivers who read newspaper while driving. And x distributed following binomial with the number of trials 100 and probability of success is 0.06. Okay, now what is the equation? Find the probability exactly 25. Okay, so that they read the newspaper while driving. So what is the probability for this particular event? So as usual, I factor the first step. So Px equal to, so it becomes between two values. So Px, so if let's say put it at term, so this becomes 25 minus 0.5 x, and 25 plus 0.5. This becomes P 24.5 X 25.5. Then transformation P 24.5 minus, sorry, we need to check, right? No one remind me. Okay, so check the condition. The first condition is n equal to 300. Obviously, it's greater than 30. Check. Second one, and P 300 multiplied with 0.06. You will get what? 18, right? So it is greater than 5. Okay. Third one, NQ is 300 multiplied with 0.94. You will get 16.92. Again, greater than 5. Okay. So this become normal. Okay. Become normal. Mean this will be NP, that will be 18. And standard deviation, NPU. Okay. NPU is okay by 16.9. So you have 16.9. So minus 16.92 divided by minus 18 divided by 16.92. Okay. X. From the X, we are talking Z. Z and 25.5 minus 18 divided by square root of 16.92. Okay, so you will get P. So you will get what? 1.58 Z. Okay. Between, and this will be 1.8. Okay. So if you draw 0, 1.58, 1.82. Okay. So you can say finding the probability for P Z between the largest part, the largest part of your area is it will be 0 until Z is 1.82 minus P Z from 0 until 1.58. Okay, so for 1.82, 1.82, 1.82 is 4656, 0.4656 minus until 1.58, 1.58, 1.5898, so 0.4429, 0.4429. So you will hear 0.022, or in terms of percentage, this will be 2.3%. So interpret the probability calculator. Okay, you can say there is 2.3% chance that exactly 25 drivers, nation drivers, read newspaper while driving. Okay, so that's how we interpret the value. So very unlikely. Okay. Any questions of our class? If no questions, I want you to try this on your own. Almost the same. Okay, forward. Last but not least is the one that we need to cover is normal approximation of Poisson probability distribution. So this is the last part. Now, how about Poisson? So I think everyone should know that Poisson, when we involve Poisson, it will be simpler than binomial. So we know that originally x following Poisson with parameter lambda. So when we approximate using normal, so the mean will be taking the value of lambda, the variant also taking the value of lambda. As simple as that. What will be the condition for this approximation can be done if your lambda is greater than or equal to 10. Okay, certain textbook, they use lambda greater or equal to 15. So in our case, if you look at the distribution, okay, for x following Poisson, lambda equal to 3. If we increase the average value, it becomes symmetric. So by having 10 lambda equal to 10, it is approximate to normal. Okay, so that's why taking into account n for lambda is greater than or equal to 10, we can do the approximation. Always the same because we are talking about discrete, okay, two continuous. Okay, so that's why this particular continuation correction factor will be again applied when you solve the problem. Okay, now let's look one example and then look one exercise, then finish the class. Okay, an average of one customer for 2 minutes arrive at a checkout stand. So in your case, supermarket counter, right? Supermarket checkout counter. Okay. Now, what is the probability that more than 35 customers arrive at the stand or at the checkout counter during a particular interval of 1 hour? Interpret the probability value. Okay. So in your textbook, they use two different variables. But in my case, I use only the same x, but different intervals. So I can say as x is the number of customers arrived for 2 minutes. So x is following Poisson 1 for 2 minutes. Okay. What if I'm talking about 1 hour? So 1 hour means that 60 minutes. So for 60 minutes, divide by 2. So x will follow Poisson lambda equal to 30. Okay. But this one is for 1 hour. The first is for 2 minutes. Okay. Now, what is the probability more than 35? So Px greater than 35. So greater than become greater than or equal to plus 1. So this becomes Px greater than or equal to 35.1. Then apply the transformation Pz greater than or equal to 35.5 minus 30. Okay, so in this case, x become normal with mu is lambda 30 and variance is lambda 30. Okay, so divided by square root of 30. So you will get Pz greater than or equal to 1.004. But in your case, we are using 2 decimal points. So that's why we stop until 1.0. So this one is So for if you draw to imagine what is the value of the probability, you have 1 point z equal to 0 here, 1.0004 here, greater than. Okay, so in this case, it will be P z greater than or equal to 0 minus P z from 0 until 1.004. Okay, so you will have 0.5 minus 1.00. 1.00 is 0.3413. 0.3413. Okay. 0.3413, which is equal to 0.1587. Okay. So that will be your probability value. Interpret the probability. So if you put percentage, almost 60%. Okay. So you can say there is 60%. There is 60% chance. There is 16% chance that more than 35 customers, 35 customers arrive at the counter in 1 hour. Okay, so that's how we interpret. Okay, so for the second exercise, so for the first exercise, okay, so an average of 5 customers per hour come to use the ATM machine. So we are talking about the number of customers using ATM machine. X following Poisson, that will be 5 in 1 hour. Okay, now the question asks you from 8 to 5. How many hours are there in 8 to 5 class? How many hours from 8 to 5? Class, how many hours from 8 to 5? Class, are you all with me?
9.
9 hours, madam.
How many hours from 8 to 5?
9 hours.
Class,
9 hour.
no one is answering. Class, how many hours from 8 to 5?
9 hours, madam.
9.
9, okay. So, if for 9 hours, then you have to multiply by 5. So, X Poisson, it becomes 45 for 9 hours. Okay, so since lambda is equal to 45, is greater than 10, then we do the approximation. X becomes normal, lambda become the mean, that will be 45, and the variance is 45. Okay, now what is the equation which asks more than 30? So X greater than 30. So do the correction factor. So the correction factor will be greater than or equal to by adding 0.5. So Px greater than or equal to 30.5. So apply the transformation Pz greater than or equal to 30.5 minus 45 divided by square root of 35. So you will get Pz greater than or equal to you will get what here? Negative 2.16. So if you draw 0, negative 2.16 greater than, so you have 0.5 and you have this part. So this will be p back greater than or equal to 0 plus p back from 0 until 2.16. That will be this part. So this will be 0.5 plus, if you look at your table, 2.16, 2.10, 2, 3, 4, 5, 6, 4, 8, 4, 6. So you will get 0.9846. 846, okay? So what is the probability? Then this is the probability, highly likely, okay, 98.5% chance that this event will occur. Plus, so for the second question, I think I'll just leave it to you, find on your own, okay? So this one is Poisson. So please do the what we call the definition, the distribution, the original distribution, the transform distribution, the continuation factor, correction factor, then apply the standard normal. Okay, so this standard normal transformation, and then finally you can get the answer. So if I can simplify, okay, so we have seen three types of probability distribution. The first one is binomial, second is Poisson, and the third one is normal. Okay, so X following binomial, X following Poisson, X following normal. And somehow, at certain level, we can approximate Poisson approximation for binomial by looking at the given criteria. The same also normal approximation of binomial, so there will be criteria that need to be fulfilled. The same goes to normal approximation of Poisson. There will be also conditions that need to be followed. Okay, so class, I think I'll just stop here. Let me stop the recording first.